Okay, we're back from lunch. Um, did you guys have any? I just wanted to know if you had any questions about where we're at so far. I think we're going to
Um,
get a little bit deeper into planting stuff. This.
I don't think I have any question. I think I'm just gonna have to review the recording later.
Sure.
But
Yeah,
yeah, been kind of tuning in and out with this project that I'm working on right now. So
yeah, that's awesome. That's one of the reasons why we're recording it for sure. So, um, awesome. So let's look at the next script here. This is planting and nutrients, and the idea here is I just wanted to show if I turn off plants and our tree blocks. There we go. Yash is here. I can, I've got a bunch of plants placed. This is the, Yash, by the way, this is the next thing. This is the planting plus nutrients, part two. I just opened my Rhino file, my Grasshopper file. But right now we're kind of zoning in on these nutrients. I hid the plants and the trees, which are baked into the file automatically. And right now we're looking at a, and if I zoom out a little bit, we get a legend. This is our organic material, right? OM. And our pseudo species. So this is a schedule of all the pseudo species that are being placed if I turn these on. Okay, so those are all the plants that are being placed. We'll look at how to get a schedule like this. We also have a schedule of trees, which is spaced out a little bit differently. And then we have a bloom calendar for all of these sort of pseudo species. And you could also think of the bloom calendar as a harvest calendar, right? Like you could input information and think in terms of a harvest calendar. If you're harvesting different things, like it doesn't have to be food. It could be, oh, like during this time, like we have these leaves or whatever. So there's interesting ways of thinking about the functional outputs of plants as a seasonal element. Now, in terms of the nutrients, what's happening here is for the pseudo plants, each one gets assigned values according to pseudo plants are interesting because you give it randomly gets given a plant type, unless of course you're only asking for trees. You can filter by trees, and it will provide um, three characteristics that are plausible, right? So if it's a conifer, all of the cascading characteristics of that conifer tree will be plausible. And so it has all of the different actually ERA plus some columns, all of the ERA data plus more. And but you always know it's going to have data in all those columns. That's the one advantage this as well. So some of the new columns are actually these nutrients. So one is organic matter, another is potassium, and what we're doing here is mapping those out. And you can kind of see the values and the ranges changing, as well as the layout of which plants have which nutrients, and so that's an interesting way that we can begin to map out nutrients. And again, as I said before, it's not the most finished idea. We're still kind of coming up with ways of using this, but we think it could be really promising for taking, again, as always, things into account that we wouldn't normally be able to take into account, that we can utilize in our design as important factors for a thriving landscape and hopefully community. Because if a productive landscape can produce things for a community, and that's live. Um, I'm gonna now dig into the script and kind of like the larger thing, but that's sort of where we're going with this particular script. So there's a lot of pieces, and I'm gonna try not to sort of revisit too many of the things we revisited in the last script. And if I am, please tell me you're bored. Okay. So if we look here, we're gonna have a look at areas a little bit more. and sort of things we can do with areas. We have topo, which is similar to what we did before, but we're using a different kind of a mod that pushes the mounds up and down. We're doing a collage, which is also sort of part of the area's idea. And then we're building an environment using sunshade as well as water flow. And we're using a formula to create moist, wet and dry soils based on the number of flow occurrences that are happening within that. We're generating sun vectors here. We have uh, we're placing plants in a few different layers. So we have layer one, which is the trees. So we place those, and then we're doing some interesting things with adjusting the age and things like that. And then we analyze I'm forgetting which some of these are, but we analyze the sun exposure, and then when we place the understory plants, we're using that sun exposure map based on trees to place our understory, or our perennials. Then we have this nutrients analysis, and then the rest of this is like, you know, schedules, bloom calendar, baking out trees and plants, and then this other thing that I showed in that slide, which is, let me actually zoom on that, which is breaking up, like if we have soil moisture and sun exposure and we combine those layers, we get a new layer called soil moisture sun exposure. And I'm then kind of taking the names of those and assigning colors to them so that we can visualize that. And it's a few steps, but I think this way we can like really control what those colors are. And yeah, it's stuff like this that, first becomes a prototype in Grasshopper, and then I'm like, there's got to be a way to integrate this into the work, what am I trying to say? The framework of LandKit. Let me zoom up here to areas. So for areas, we're bringing in the site boundary using our layer pipeline. So it's, the site boundary layer. Oh, it's drawn here in red actually it's here, the red boundary. We actually can assign a color, site area, and then I have one that's kind of the regular area, and then I have one that's lower, and I'll show you why I use the lower one, but it's more likely than not relating to the collage tool. So if you set up your collage where the layers are all stacked, you can flatten them, and it does all the trimming for you. We'll look at that in a minute. I'm doing some patterning in order to achieve our, agricultural this. You can see how that pattern is actually influencing the topography. Just to show you, I'm going to unplug that. I know I'm skipping around here, but you can see if I just unplug that, it's going to change the topography, change the water flow, change the environment, change how the plants are landing. It's all happening, which is the beauty of all of this. We'll have to investigate and see what's taking the longest time in a minute, but see the trees. You can see how the plants are placed there. Um, so I'll just leave that unplugged for the moment. But it's creating a pattern of these areas. And then I'm basically just creating areas, and I'm making them green. And then I can use that later. So later I have the low area and the all plot areas. And then I collage that. Now let's talk about that. So if I have like a plaza area, and then I have got my CVS thing here. I have like my planting plot, and I arrange those in 3D space. So I just like lift this one a little higher. That collage tool will flatten it so that this is now cut out of this shape. And the cool thing about that is I can change the parameters of that layer and it updates the plan. Like I'm not going and retrimming all these curves and making new hatches and everything else. Like the tools will spit those out for me, but the area is kind of like the source material. And if you combine the areas, it creates this collage. So if we just kind of preview what that looks like, we have kind of our site area and then these plot areas, just like we had in our paving. If I look at this in 3D, in this last step, we projected these to the graphene. Let me turn off this water flows. Here we go. You can see how that's there. I'm upside down. Okay, there we go. Um, but you can see how the topography is influencing the water flow. So if you just turn this back on, you can see that even just subtle topography can really channel water into a swale, just kind of how water works. Flat, flat ain't flat. Flat's gonna turn into something else eventually. So how do we kind of account for that? Now, we've got all those plot areas. We create our topography. We're also cutting contours is a new tool that we have as well that allows you to get your contour, your text baked out. And the reason these are different, I think, is because it's they look different because we're at a crazy angle. There we go. They look good now and plan. I think I moved them up above the trees so that you could see them above the trees. So that's why I'm moving it up 64 feet. Mm. But the cool thing, you can change all these different parameters for labeling things. And this is really good for plants, for contours, for everything else. But the contour component allows you to take the mesh, cut it based on certain steps, have different spacing for your labels, and then get contours, elevations, and planes. So also for the spacing, you can remove this and then just not do the annotations. You can also add a cross curve that will. I just have to show you this. So if I do a curve, and I'm just going to draw on the zero layer, and then over here I'll do an interpolated curve. I can input this curve, and instead of a number, I can input a curve, and dang, not working. Maybe I'm not raising it up enough. There it goes. I think I was just moving it too much or something. So now you can see that those occur along that line. You can also change the alignment of that, so we could make this centered so that they're just all centered. If you're having any issues there. Kind of cool. Just really nice to see that. And then for topography, we're doing the custom geo set, customizing using a mesh that represents our existing topography. So in the other option that we created, we have we had break lines that defined that plaza. But a lot of times you're working with existing topography. So if we just turn this on, this is a mesh that I downloaded, you know, and that represents this topography. So you can input that using this other geo slot here. So you can input it as other geo. And then you build your topo and we smooth it out a little bit. And we're doing 2 foot spacing using our smooth mod. And then we are doing the mound, we're shifting the mound based on these plots. So if I look here, I've created a grid of these plots by offsetting the curve in a little bit and then turning that into surfaces, joining that all together as a mesh. So it's just one attractor. And then um, and then when we plug that in, as we saw before, so right now it's not plugged in, this mod. I love to do this where I'll skip the mod and see what it looks like with the mod or without the mod. And it's a great way to, if you're like, what's going on? Like what's layering on top of something else? You can sort of work your way back and say, okay, start here. And then when I do this mod, it does this. And that can help you understand those steps. Plants and trees off. I can see now that there's topography changes that are being influenced here. So we have a set height, an offset. In this case, I don't really have an offset, 0, and then the actual spread, which is sort of like the run of the slope, is 2 feet. So in this case, it's not a set grade, it's a relative grade according to whatever the grade was. So if you have extreme slopes and you're trying to do this kind of sculpting things, just think about that. It's okay, it's kind of okay if you're going in, like if you have a slope running down and then you're doing a swale along that, and it makes sense. But if you're trying to kind of create ridges, you're going to get like steep sides and shallow sides. But that's just with this sculpt tool. We also have a grade tool, it just requires the geometry to be in 3D. Um, and then we draw that topo. Sorry, this one doesn't have labels. You can always bring in, there's a plugin called bifocals, which is really good. If you bring that in, it'll label everything. I've labeled a lot of stuff here, but I haven't labeled everything. And then we do water flow lines. Be careful with this one because you you want to make sure that it's not too dense. Like if you have a large site, start with a point definition, and that means that like a large grid size of where the raindrops are falling. Do like 20 feet, or if it's a really big site, you might need to start with like 200-foot spacing. The cool thing about the point definition, it's similar to the you know, contour annotations, and that you can either provide it a number, which provides a grid spacing, or you can give it a bunch of points that will be where the water droplets start, or a single point. If you're kind of like saying, hey, where does this, depending on where I'm at, where does that water droplet go? Um, and then we're previewing it with the bake preview. We're creating an environment. This is pretty straightforward. We have a boundary. We have our cell size and our topo. And then we have our water flow as curves. So this can come in for this occurrence layer. The occurrence layer, we have originally set it up for this flow, but it can also be occurrences of plants, which is good for the nutrients, things like that. We can also use it for other occurrences of other kinds of point objects. Well, so we label that as water, and we diffuse it, meaning we blur. So if we were to preview it, let me see, do a draw layer as mesh. You plug in the environment, you plug in the layer name, and you end up seeing, must have something turned on somewhere else. You can kind of see it here where we have, see this. Oh, I think I see what's going on. Turn this on. There we go. So if you look, you can see the density of that water. You can see that there's a lot of water here, a lot of water here. There's a huge zone that just gets really wet right there. Um, and what we then do is we say, okay, according to the number of occurrences of these curves, we just look at the curves again here. Good plan. So many layers. I'm constantly doing this, turning things on and off. That's a key to being nimble in computational design and 3D design. Turning things on that you need, turning off other things. Something here. That's strange. I wonder if it refreshed when I added those. Not it, that is very odd. Well, it is darker there. I'm not sure what's happening. That is really weird. Um, I literally have a diagram that shows this. No, that's not right there. Something is up. I think it might be a Mac thing again. But running into bugs, this is part of the game. You got to make sure that it's you and not the software, or not, that it's not you. If you think it's the software, oh, very odd. I've never seen this before. I have a sneaky feeling that it's breaking. Like it looks like it's evaluating a few curves, and then it's not making it. No, I'm gonna hit refresh on the whole script. That might do it. I've never seen that before. Strange. Oh, bizarre. Mm, yeah, that's something I need to investigate. The idea is that the water flow reflects the, you know, actual distribution of water here. Mm, That's the most perplexing thing of all there. All right. So the way that this gets assigned is that we what we want to do is want to translate this number of water occurrences into moisture. And this might look like a crazy equation, but this is a formula basically that says, if the water is greater than 6, then it's going to be wet. Otherwise, if it's going to be moist if the water is greater than 2, otherwise it's going to be dry. And that seems like a crazy thing to have to be like, I don't know how to write that equation or whatever. But I I've been writing Python for however long, and I gave this to ChatGPT, right? I was just like, give me a formula that basically says above this amount of occurrences, it's going to be this, below it's going to be that, and it produced this one liner for me. And so if you provide it with the context of like it's basically Python code, mm, you know, and what it's doing is it's saying in any given cell that's where the water value is higher than 6, it's going to be wet. If it's lower than 2, it's going to be dry, and in between, it'll be moist. And so you have to pay attention to that when you're looking at like your grid density and things like that, because this is a little bit. It's kind of like a quick, fuzzy way to figure out soil moisture. So just this is not a super duper scientific way of figuring it out, but it is a quantitative way. So we do know that there's going to be more flow in certain areas. We do know that it's going to be wetter than other areas. And so we have to kind of figure out what does wet mean and what do we think wet is going to mean on this site based on what we know about soil and things like that. And this equation will change. And I'm just going to pause here and let you know that I know we're not talking about a lot about like literal plants in this workshop yet, but I think one of the things you have to understand is we really need to understand conditions and set all these things up in order for the planting to work. Right? It's a very important part of this. Anyway, so we get the layer formula, and then this is a little hacky, but we're renaming that from moisture to soil moisture. The reason we do that is because soil moisture has a space in it, and we can't do that in this equation. We can't have like the answer have a space. It has to be like basically like Python code where the variable would be either have an underscore or no space. Um, and we change it to soil moisture, which is the value that's in the ERA database. So the ERA database has all these different values like soil moisture, and I should probably open that up. Ben's always good about remembering to open that up. I'm just going to open this numbers. It actually looks pretty good in uh, numbers on a Mac. So you have plant type, scientific name. And as you can see, these column names, they're capital, they have spaces, and that those names are really important when you're comparing that you're assigning niches to your plants. So if you want your plant to have a, you know, some of these don't get translated to words, and I'll explain that. But mm, if you want your, if I can find, there it is, sun exposure. So you have sun exposure, and it has or soil moisture, and it has a space. So it has to match that. So this environment layer match what's in the spreadsheet in order to work. That soil moisture layer is important. Now that we have the soil moisture layer, we go down here, and when we place the trees, we don't need to analyze the sun. But when we've got another version of this that comes down here, and after we place the trees, we're analyzing the sun exposure so that when we go to place our understory, that they're following the logic of those shady and sunny conditions. I'm really perplexed by there was something else that was funny that was happening earlier, and I don't know if it's Zoom or what, but that is really because it looked fine last night. I don't know what I did. It might be a glitch. Um, so what have we looked at here? We've looked at kind of this first grouping. So if we're doing trees, I'm using pseudo species to get a using the filter. So under the filter, we can do all, we can do trees, shrubs, herbaceous, grass, vines, and then yeah, so 0 would be all. So if you're just trying to do just a mix of plants, that's any and every plant, it would just be 0. Um, and then we tell it how many we want to create. So we're creating 6 species here. We have 6 species of plant of trees that are getting filled. Sorry, just let me clean up here. Um, we're also changing their cluster radius to 0, just to like set that and make sure that it's set. We could also have a cluster radius that's like 30 feet, and we'll see a whole different distribution of trees in that case. Maybe not. Maybe 30 is not big enough. Maybe that's because since they're trees, it needs to be even bigger for them to actually have clusters. Um, so one of the things you may have noticed if you've done any of the planting stuff, the plants, when we just changed that, literally nothing changed. And that's a new feature where um, not that nothing changes ever, but that if none of the input conditions change, when you rerun the script, all the plants are going to land in the same location. And that should be true for a lot of conditions. Like you might be able to, change certain things or whatever. And there's the the randomness of the placement is based on like the area, the amount of area on the site and kind of where it's placed. So if you change that site size, it's going to randomize. But if you don't, it's going to still follow the same random seed every time, which is cool because it allows us to maybe just not be confused about things that are shifting around or changing. Mm. That are following the same rules, but they're kind of just it's kind of re-randomizing certain things every time. So what else do we have here? We have all the different plots. But we have all these plots that in green here. I'm offsetting them a little bit and filling those with points. So I'm just putting I turn them all into one single mesh and then I place points in those areas. And then I use that point pattern to place plants using the pattern placement. So we have our large site area. We have all the different, well, we can also place plants based on the plot areas if we wanted, but I'm just saying, just place them anywhere. Um, and then we have our environment, which has our soil moisture conditions, which I need to look at. And then we have our plants coming in, plant list of trees. We have the pattern. So there's all these things that come together in the layout component, right? We saw that in the other one where we had, you know, we created areas and we had the area shape and then we filled the plants into those areas. I'm not doing any rules here. I could do constrained if I wanted to. Like I could constrain the trees based on their moisture conditions, but I think I was just assuming just fill them in and create a canopy cover for now. But you can, it's just anytime you add constraints, it makes things harder because you're trying to, even though it's helping you solve for these things, you have to make sure you have the right list, et cetera, et cetera. So it makes building demos a little challenging because you want to solve those things on a project. You have to make sure that you're exposing your project to these kind of tests. But it does, at certain stages of the project, you might want to back off on how many things you're solving for. You might say, hey, this is something we're going to actually detail that we're going to get into a little bit later. But if it's something that we can easily build in now, let's do it. And that's one of the nice things, these tools. So another thing I've discovered recently is once we have an area, here's here for a second. Once we have an area when it's filled with all these trees, right? If I were to just pack those trees, so this is the packing component. If the tree is big and I've got another big tree, like this guy's going to get forced out of this little area, right? And we're going to only have one tree. But if we want those trees to kind of be there and create a canopy where they're together and they have space, but they're not, you know, maybe they're creating greater coverage for whatever reason. Um, we can change the age of that area, meaning changing the age of all the plants in that area to 2 years. So you can make it so that, hey, the radius of this tree is actually smaller now, and so is this one. So they're going to just bump up against each other. But if I have, these other three, they're going to pop out the, zone. So you can adjust where that year is. And I know that I'm going to change it later before I show the plants. And so this begins to introduce the idea of time and how do we use time to sort of think about what's ideal spacing for things, as well as how is the environment going to change over time, particularly with shade. Are there any questions? I know you're all kind of slightly distracted by other things as well right now. Keep going. So like later I'm setting the tree age to a set year. And I'm kind of like wanting to see what this thing looks like at year 10. So I'm setting the trees and the other perennials at year 10. And so when I evaluate the sun exposure or the understory, I'm doing so at year 10. There's different ways to think about this. One might be to evaluate at year 0, say, hey, these plants have to survive. Another way would be to say, let's do year 5, and then we can work forward and backward from there and kind of say, like, which areas are we going to need to like really protect the plants, or maybe we have to plan on planting more plants later. Maybe we just need to make sure that those plants do well in shade and sun in those zones. Um, then we have, yeah, so in order to do that, we're actually taking the plants out and creating little geometries. So we get all the symbols. Let me see how this works. We get all the locations of the trees, and then we have all the tree symbols that are at 0, 0. But they're organized in a data tree. So we haven't really talked about data trees very much, but if you see here, it's like 0, 0, n equals 1, 0, 1, n equals 1. See that in the little yellow panel? That's like a branching data structure. So each of those is a different species. So for the symbol, there's only one piece of geometry for each branch for 0, 0, for 0, 1, and for 0, 2, and 0, 3. If I go down here to locations, I have multiple locations per branch. So that means that that first species appears in 4 locations, and the next species appears in 7 locations. And then in order to array those, we use the orient tool. So that orients some sort of geometry starting from an existing coordinate system. In this case, it always starts at 0, 0 with x, y as the world plane. And then it reorients it to another location, which is these final points, which effectively become planes when they get plugged in here. You have that. You can also, if you wanted to build a bunch of, like, I could just do a circle component and just visualize all of these trees as radiuses. See, I'm just see them there in the. So there's different ways of using, and it's similar to like the cut and uncut pavers, where as we go, sometimes we expose some of these things because they're useful. But just so you know. So we have these 3D plants now in place, 3D tree meshes, and we're going to use those for our sun exposure. So we have an environment that we're adding sun exposure to. We have sun vectors. And the way that this is working is actually have this is funny because it says Osnabrück and then the anchor points for a project we were working on. And but what you want to do is you want to set your your file for this. This is a little script we made. It's really dumb. It's just like where did it go? It's just a few lines. It gets the Earth anchor point. It gets the latitude and the longitude of the Earth anchor point. And so if you go into Rhino and you set Earth anchor point, you can set your latitude and longitude of your file, like wherever zero is, right? Like you just want to set the file's Earth anchor point, and then this will pull that data out. Or you can also just enter it here. But the neat thing about this script is, like, if I have a file and I'm always setting the Earth anchor point for multiple things, this will just grab that Earth anchor point. Nice. I have two methods here for doing the sun vectors. There's one on a Mac where you install Ladybug, like the latest version of Ladybug. And then this version will create, using a script, it will create the sun vectors. It doesn't need Ladybug installed. It's because Ladybug used to just be all like Python. Um, this will work without installing Ladybug, which is nice. But here's the hitch. If you're on a PC and you have Ladybug, like the more recent version installed, both of these will produce vectors. And you don't want that. And so it's worth paying attention to if you're on a PC with Ladybug installed, which usually we're working from zero here. Like most people are just like, hey, like I'm just learning all this stuff, and they don't have things like that installed. So, but the Mac, it will tell you, hey, you need Ladybug installed, and then you install it. Um, anyway, so I get those sun vectors, and those are based on a growing season from 4 to 10 months. So so from April to October, and that gives me the sun vectors for those months. I use those vectors down here to analyze the sun exposure using our environment, our tree canopy, which I'm going to now hide, the sun vectors, and then the start and end month need to get used again. And that adds a layer of sun exposure to my environment. Uh, and then, as I was saying before, I'm taking those two layers and I'm combining them using the draw layer as shapes. And it basically, I combine the two layers and then I bring them, make them, turn them actually into shapes. And this is kind of awesome in the sense that, I'll just bake this. I can take these shapes. So if you have an environment and you want to break it down into shapes, this is an amazing way to do that. If you want to create a diagram, um, it does have its flaws here, like it does some weird things. But if you would just use all the big main shapes, you could create a pretty interesting diagram this way. And it gives you, again, one more thing to use for like design, like for this whole design. But we're just visualizing those things. So we have trees, we have sun, let's look at our understory. Again, I'm using the pseudo species for my plants. I can bring in CSV data. I could do herbaceous plants. um, And then I would just need to reference this. So that one, get the ERA. And now I have a list of 40 plants. Yeah, see, now that number is working. I have 40 plants. And then I plug this in here. And instead of those crazy pseudo plants, I get a bunch of plants that are a little bit more, you'll recognize them as ERA because what will happen is some of them will be gray. You know, they're not all going to fill in because they have different constraints. May actually because we're having these issues with this environment, this water, this moisture thing, I'm going to turn off that parameter. So the way I do that is I'm applying niches. Maybe this is where no, that's not. I'm going to turn off the soil moisture as an option or as a constraint to placing plants and just see if that changes anything. Very odd. What spooky's going on? There we go. That looks a little bit more right. Um, let's use the pseudo plants for now. This is one of the reasons I feel like it's like you start to limit this list and then, you know, so one of the things that we found with firms to adopt this is the plant data. Like going in here, and it's best to edit this in open office because it doesn't turn if you have like certain ranges, it'll turn those into dates, which is really annoying. It'll do that in Google Sheets, it'll do it in Word and in Excel. Like, so this would become February 10th, and this would become September 15th, right? Like it's a range that you want it to have. So if you only edit it in Open Office, it's going to look a lot better. Now, the cool thing is all this data is kind of here as like a starting point. So it's like seed, you know, like seeds. You want to build your own database, you can very easily search for plants and then copy those out and start creating your own, plant list for a project. And then you can go and say, hey, like what data is kind of missing here? I'm going to be more specific with my color and use a hex value, or I'm going to add another column that's like some other attribute that I want to test for that's not in ERA. Like you can really customize it. And I think it's a really important part of the step. It's all this preparation, right? Because what we're doing is automation. And we need all these kind of rules and all this data to be kind of right before we get to that final point where it's placing the plants for us. And it's like kind of a garbage in, garbage out. So if you don't have decent data, it's not going to work. And in my case, you know, we're just I just was like, hey, let's plug in the CS, the CSV and see how that works. Um, and it's from the ERA, which is not the most perfect database. The pseudo species are a little bit more reliable. And part of what's happening too is I'm generating 100 different species. And and that's giving me more opportunities for things to be successful. Not totally certain what's happening with these others. Now, I create a pattern within each of these plant areas. So I use the pattern tool and then I get the center of each. Yeah, I'm going to do the point. There you go. So you can see that there's a pattern here. These green points create a pattern underneath. And then, I can either fill them as a pattern or I can fill them in another way. So if I plug this into here, you can see it fills in slightly different ways given either option. And as before, we could, if we wanted to, we could change attributes. So I could say change attributes. So you can also change plant data values as well. But I'm going to say, given this plant list, I'm going to change every single plant. So you could, if you wanted to, you could only change certain plants. So one thing we could do is say, do a dispatch, which basically gets every other plant. We'll just only change every other plant. I'm going to graft this. Exactly. And then I'm going to do my attributes is going to be or underscore radius. That is going to be equal to 3. And then if I plug this in, well, also it gives you, for this, I always find it's a little confusing. So I made it give you a message. So it says, okay, change the cluster radius to 3, change the cluster radius to 3, etc. And it changed, it's just telling me that it changed them, which is good. So now if I plug this in, we'll be able to see that change. Now you can see there's like clusters of plants. Because there's so many species, I think oh, it's also, remember, it's only doing half the species. So some of these are not clustering. That's kind of how you sort of like John Cage preparing the piano before that, you kind of have this like there's a little bit of randomness in terms of the performance going on. But because it's prepared in a certain way, it sounds a certain way, it's acting a certain way. Um, okay. So then once I get the plants, I'm packing those. I'm setting the age, as I said before, to 10 years. And then I do all the fun stuff. I bake out the trees and the plants. I like to just set this to true so that it keeps baking every time I make changes. It doesn't take long. It's just a few milliseconds. Um, And then I have my legend here, client schedule. And the cool thing is I can also change my fonts now. And so it's gonna be any font you want. You just give it the name. Change the size, change the color, which layer to bake onto. We have a bloom calendar, which is going to take all the plants and you give it, in this case, I'm saying, okay, take our initial point location that I set here, and then it shifts it up in order to draw this legend. Mm. You can also do two different graph types. So you can do a linear graph. You could also do a radial graph. In that case, we might want to shift, but kind of fun. Um, and then drawing legends and things. Okay, so now the last piece of this is nutrients. And it seems like, you know, such a small piece at the end, but so many of the things that we've been doing are important. So getting, we have our plants, they're in different locations for different reasons. Mm. And then we have the ability to say, get the current plant data. And this allows you to get both plant data and attribute data. What's the difference? The one way to think about it is if you have a plant, that plant has a bunch of attributes. I'm just going to kind of make like a little thing here. And those attributes are like the plant's width, it's the height, it's the color of the plant, it's the self-spacing, it's the cluster radius. And some of these things are like not quite about the actual shape of the plant, but they're attributes of the plant. Whereas data is more of like what's in the ERA. It's just like all these different things. Like, oh, it like is a great place for, larva to be, you know, to live and things like that. So all this is data, even soil moisture and things like that. Um, when we apply, we can apply those niches like we did it before with sun exposure and soil moisture. We can apply sun exposure as a constraint. And that's just it applies data as constraint. And you just tell it which layer you're using. So attributes are the characteristics of the plant. data keys are kind of like the extra, it's like this, oh, by the way, this extra list of all these things, just, it's like a manual, that comes with the thing. Um, and but we can use those to build our constraints. So what we can do is we can either say just plug in the plants and it will give you all the attributes and all the data keys, or you can actually narrow that down and say, I just want the nitrogen values for the data keys. And so if I do a double click and create a panel, my panel shows me that I have, these different values for nitrogen for these plants. And then we can create a legend basically by taking the plant location, converting that nitrogen value. So we're basically graphing it in 3D, right? We're creating a graph. So if I look at this, I'm actually creating a mesh that's in 3D and it's showing those nitrogen values. Let me hide all this other garbage. This is our nitrogen like heat map. You could, if you wanted to, you could get fancy and you could convert this into sub D. It doesn't keep the colors, unfortunately, but you could map the colors, or you could like do a you could do something. Um, I don't know why they don't do the color mapping. That would be a cool thing for sub D. Um, yeah. So it's a graph, and then if the neat thing here is if I just plug something else in, like potassium or sorry, phosphorus or potassium or organic matter. There's also we have micronutrients and magnesium. There's a few others but it's all just in the pseudo species. The neat thing is if you say, hey, like, how do we how do we think about like where nutrient loads are going to be heavier or less over time? And you could like use this potentially for maintenance regimes or for adjusting like how you're thinking about the soil, or you could even place based on nitrogen as a constraint. Like you say, okay, only nitrogen loving plants near like the large nitrogen fixing plants. Something like that. And you can, that's similar to the carbon stuff that we've done in the past. And we don't really cover carbon in this workshop, which is probably crazy. I was thinking I would just show you guys carbon. We could do it really fast here. So we have the collage that we've done. We have those plant beds and the got plant beds and then the areas. We could do the carbon. There's calculate carbon and then there's materials. Change it to land use. Yeah, add land use to areas. This is I changed the name in the last release. This is the Sasaki carbon database is like in here. And so what I can do is I can say create a button and plug that into there. It's broken because it doesn't have carbon values assigned. I if I hit go, it creates and it just popped here. No, it's on the wrong screen here. And I'm just going to change my we're hoping to make this more integrated. You guys see that there's plant bed and site area. If I click on plant bed, I can go and pick what that thing is. So I can say, oh, it's actually the plant bed is going to be softscape, going to be a cultivated garden with high intensity, temperate, whatever, so you pick it, you say done, and then you say site area is going to be softscape, and it will be, hydro seed turf because these are just going to be like lawn paths or something. Pretty sure. Or maybe it's a native turf mix. Let's get, then we say done and done. Now if we go here, it shows us, it gives us a list of things. So this allows us to build a legend if we need to. So we could say, um, it actually shows us curves, how the stuff will change over time, colors and totals. So if I do a legend and I say, what's the, oh no, I'm thinking of something else. So basically the totals here are, we have different materials. We have our plant beds, and then we have our totals. So this is the, I think these are actually relatively carbon positive because it's all green. Let me just test and turn one of these into, oh, you guys can't see that. Sorry. You're on the wrong screen now. I'm gonna just change the site area to like a hardscape and see what happens to one of the things here is it's hard to like find, right? So I'm just gonna do a CIP and done. And now you can see, yes. Okay, so let me change screen we're on. So so now we can see that we have the materials, mm, and we have plant bed, site area, and the total. So we're carbon positive for the plant bed, but it's nothing compared to the site area, which is covered in concrete, which would be all these paths. I did that as like a example here. And then so the total for the site is this, and I think this is kilograms of, so you divide this by 1,000 to get kilotons, or yeah, metric tons of carbon. It's a lot to do all that concrete. It'd be crazy. So it really makes you think twice about concrete. Concrete's a crazy thing to have to be using. And this is why I'm like crazy about all these plant materials and using wood and thinking about like what are the nutrients? How do we grow things? Mass timber isn't gonna grow itself. Mm. So yeah, so we have those fun things. Carbon is good to understand on your site. And yeah, that's pretty much that that workshop demo. Let me see. I'm really disappointed about that soil moisture. I do not know it. Maybe I wonder if I should quit. If it annoying. Something. I think I need to like force quit, right? I'm gonna try to very quickly open this up. I know we only have 20 minutes left, but maybe this last one turns into homework. It's like the homework that you do for the rest of your life. Kind of. I always forget. I try to pull the grasshopper in. You have to, I know, Mac, you launch grasshopper first. So disappointing. I will say that years ago, not too long ago, I swore I'd never use Rhino on a Mac. I have really honestly been enjoying it for the most part. There's a few like little things. I really like it. smooth. They've made it a lot more like the PC version. And yeah, pretty great in that regard. Kind of, being able to zoom with the track. And I'm on a MacBook Air. I do all this stuff on it. Almost almost irresponsible. So if I zoom out here, I just want to see if we're actually getting real water values. Just have this weird sneaky feeling that it just something went haywire. Doing it again. Yeah, I don't know. I don't know what I did. Check it out. Um, okay, so let's close that. We will open this last one. I think this last one's kind of inspirational. Of course, right after I said how much I loved working Mac, it crashes. Okay, so we got to. So the idea here is like I'm creating a site very much in a procedural way where I'm using different simple inputs to sort of generate things in my site, and some of them are a little bit random. Some are based on not randomness, but on environmental conditions that emerge from decisions that I've made. Um, And there's like just a few like honestly really clear examples of it. It's imagine like a woodland play area. We're just beginning to sort of figure out like these different areas of mounds where kids can run and play. And maybe, maybe there's like different like wood structures or equipment that are in these zones. Um, but there's a big gathering area in the middle. Maybe there's like a bunch of tables and chairs or something. We don't have that, but I'm just kind of this is like kind of the blank slate of the site in some ways. Mm, but it has all these different features that the site needs. One of the cool things is that I can select, say, that point. I'm going to turn these. So I have these node points for these mounds, and I can actually launch. This is the edit custom parameters, so I can change height of that mound and say, well, actually, kind of maybe this is the king of the hill, so we got 4 feet instead of 3 feet. And if you watch, that will adjust, but also these locations of trees might also adjust, change. Um, or we could say, this guy here, is it? This guy here is going to be -5 feet instead of 8. So watch what happens. So it currently all these trees are planted here at the edge, and then I push it down, and now the tree wants to be in the basin. And the things to understand here, kind of backing out from this just like general example of what's happening, is we have the ability to do a layer pipeline where we're bringing geometry in. I'm filtering that by points. And then I have this edit custom parameters thing. So in that case, when I when I click on this, it launches this little window. And what it does is say this layer called nodes, all these points are drawn on that nodes layer. If I select one of these, you can see what happens every time I select a different thing, it gives me the parameters for that thing. And so I can adjust parameters according to each of those elements. Just change it, hit return, and it updates. It's also updating everything else downstream. But what it's doing is it's saying when I change this, the geometry reloads in this component. And the data that I've associated, I can actually pull that data out. So we have our keys and our values. And those keys and values can then be pulled out. And you can see that this parameter, this component changes. It's giving me the height, the offset, the radius spread. Height, offset, radius spread. Pretty neat. So if I were to add a parameter, just call it E and apply that, going to again update everything, but it adds the key parameter and you'll see it get added here as well. Looks like it broke something. No, it didn't break. Okay, so there's the key parameter. The neat thing is this was the hard part in writing this, is that all these are the same, like they're still associated with the same, height, offset, radius, spread, and it just adds that other one there. So we have this is like kind of an example of one of those things where I just like created this. I haven't sorted everything out. I haven't labeled everything super detailed in a super detailed way. So it's a good example. I've started to tease, I try to sort this out a little bit. Another thing I might do is move it over here so that it's very visual, right? You want to see these elements together, and because when you zoom in and out and you start looking at things and you're trying to debug or change things, you want it to be clean. You don't want it to be this spaghetti monster, right? Like that is like the joke in Grasshopper, and I highly recommend trying to avoid that spaghetti monster. But basically, I'm changing the node size based on those parameters. I'm doing something similar with the with these centralized areas. And these areas are they have a thickness to them, so I call them branches. And if I select these, mm, they're just curves, and then they each have a different width to them that I can adjust. But then they get trimmed out using the collage tool, so you can see that that shape was at a certain layer, but it's being trimmed out by these other blobs that are being drawn on the site. So it's kind of like a layering of these different site typologies, which is, you see this in almost every plan, that like certain things take hierarchy over others, and all you have to do is build your site that way, your logic that way, and it's gonna flatten, and then you can always change. Okay, so I don't really have the planting that I have in here is more about trees. Oh yeah, I'm doing them as flat trees. There we go. So part of the problem here is that I'm baking them as the same name, like the plants. Um, I'm trying to bake 2D blocks and 3D blocks, and what I end up with is I end up overriding the 3D blocks when the 2D blocks get baked. So a way to avoid that might be to change the attribute of the plant name to, blah 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 3D, and then you've got the 3D version of the block and the 2D version of the block. Another way to do it would be to get all that data, put it on certain layer, use a script to actually get it on different layers, but that's a whole other thing. I think in the future we may want to make it so that the blocks just can be changed between the symbols, so more like, say, like a land effects. Mm. Or Revit for that matter. What else? So what would be the first step? I mean, we'd want to kind of put other planting around this planted edge, right? Around this green edge. So I might start by saying, hey, where are all of my areas coming out? Well, I do the collage here, and then I'm visualizing these things here. And I'm sort of seeing all of my site areas in 3D using this visualization. I also am taking those areas and I'm cutting contours through them. Sometimes it's better to cut contours through the areas and not the original topo, because if you cut it through the original topo, areas are they're a little bit different because they're being projected to that topo. And so that there's just that the contours can be a little cleaner if you're cutting through the area. Mm. But and pulling out certain areas, for like say my border planting in order to plant the trees. If I pull those areas out, I populate them with points, really get the layer stats or the area stats, meaning I can get the geometry, the layer, the color, surface area, and I can, basically explode those areas. I use some pseudo plants for trees to fill in here. And then I'm also doing the tree pits. So I'm doing a different set of pseudo species to fill into these like little tree pits that were created opportunistically based on water flow. So I kind of took the water flow and I found a way to kind of simplify that so that where the lowest points of water flow are, we create these kind of, I just was starting to create kind of like bio sort of ideas there. You could plug that in and make it actually change the topography a little bit more. You could plug in other plants. There's all sorts of ways of approaching that. But similar to the way that I pulled the stuff out for the trees, I could say, okay, so I've got these planted areas, and maybe I get another set of pseudo species. I'm gonna we haven't done shrubs yet. Shrubs don't get enough love. Do shrubs, and then we'll do a. I'm gonna kind of do it way down here. So I'll do a fill fill area with plants. There you go. And then I take the one that was pulled out, calling it borders, kind of the board, like the planting border. We plug that into here. That's the area. And then we can do an environment too, but I'm just going to start by plugging some things in. So I'm going to plug in these shrubs, and then I'm going to just very quickly bake them. Baking plant objects. I want to make sure that I'm baking the the 3D plants. I'm going to do a toggle, make that true. I always plug in overwrite first and then bake because I want to make sure that if I do it, it's going to overwrite it. But the other thing is, because I have multiple plant things going on, I'm going to give this a particular name. So I'm going to say border, put that into there. And now I plug in the areas because I want to get all that stuff right before I plug it in because I don't want it baking and then having stuff that I can't update and whatever. So what am I missing here? If anybody's been paying attention. We can fill plants without an environment, right? But if you don't have an environment, what happens? You don't get topography. So now if I plug environment in, those plants go to the topography. Now they're filling in. This is funny because it was the tiniest area. and it's trying to fill all the shrubs in that one area. Um, it's something we could do. We could actually remove any areas that are too small before we proceed. Like, so I could do area stats like I did here. Could even use that, but I like to just have everything down here. And then I could say, given the geometry, calculate the area. That's a little heady, area of the area. And then we sort that. Oh, well, probably a better way would be say if it's larger than area is larger than say like 30 square feet, then we're going to keep it. I actually like to just do a quick double click and create one of these like splitters. And then we'll say call a pattern. You plug that in, plug in your pattern, this stuff out of the way so it's all clear. And then I'm going to plug this in instead. So now those tiny little areas, like for whatever reason, I got this because I'm doing this all parametrically generated site. I ended up with this tiny area. Another way to solve that is to like shift those curves so that that doesn't happen. But wanted to show you guys parametrically how do you fix it. So we can take that. But one thing that it's not doing right now is packing. We could pack those. And some of those plants just get like kicked straight out of the thing. How do we fix that? Well, we can change the age, we sort of set the age to like 3 years. I'm going too fast now. Plug this in here. And then unfortunately, because we didn't change the age back, it's like now some of these are like really tiny. So what we would do is we'd set the age again to, let's say, just type that in. They're back to their selves. Or maybe you say, like given the conditions here, they're never really going to get, they're going to have stunted growth. I mean, I hate to say that, but some urban conditions, you're looking at that. So if, depending on where this park is, if it's only green here and nowhere else, you're going to be dealing with pollution and wind and everything else, and they might not grow the way they need to. All right. That brings us up to a pretty close, getting pretty close to the end here. Are there more questions? I know it's a crazy day. Everyone's, you know, doing things, but I really would love to get a few thoughts here at the end if you have a moment.
Yeah, this was just super helpful, Chris, to see everything behind the scenes that's going on and just hear, descriptions of all of the components that you're using and just get that in depth. I think that's my biggest takeaway is really just kind of like breaking apart these components and kind of just looking at the individual inputs and outputs and how you can kind of tweak things. And I'm personally really interested in sort of the keys and the values and some of the changes you've made recently and how you can kind of go even further in tweaking some of these things. And yeah.
Yeah, yeah, absolutely. That's that's been a thing that we're like, oh, we need to be able to do this for these few things. And then as I worked on it, I realized this could apply to like really all kinds of things. In fact, there's certain things that we've noticed, like, if you try to use them for paths, like for certain things, like we haven't like built that logic in yet. And so we're still catching up in a few places. But it works really well. For the examples we've provided, it works really well. Um, and then probably works as expected for many, many other things. But I've noticed a few like land kit things that need to get kind of so make it so that they blend together perfectly.
Yeah, but I feel like this workshop was a really good illustration of just like the power of the tools combined.
Yeah. Yeah, absolutely. Like kind of native Grasshopper scripting and LandKit kind of together. It'd be pretty awesome.
Yeah, so I'll dig through these Grasshopper scripts that you provided with this workshop and, play around.
Yeah, absolutely. And let us know if you need help. I'll just remind you guys. One last thing, I'll share my screen one more time. On our campus page, which is always where we're going to put like all the resources and stuff. So if anybody's ever like, well, how do we learn how to do this or whatever, we've got upcoming learning sessions, and these are getting a little skimpy because we just haven't set up our 2026 schedule, but we plan on having, planting, paving, topo, um, and info sessions running from here on forward, right? That are just going to be available for everybody. And then you can just go and sign up for them. We have them in a calendar version as well. And down here, we've got an office hours calendar. This is kind of a mess because we're in all these formats, but the office hours, people weren't able to use the Google links in some cases. This way they can just kind of go and um, create a copy in their calendar. Lots of resources for people if you guys need help in office hours. You need to talk to me. Let me know. Mm.
Yeah, thank you so much, Chris.
Yeah,
Really appreciate
yeah.
it.
Thanks, Chris.
Thanks, guys. Have a great day, and appreciate you joining on a Saturday.
Yeah, enjoy the rest of your weekend.
Yeah, you too.
Bye.
Have a good one. Bye.